so we're going to finish this up. We've got multiply. 4 times 6, which is 24. Then you're going to multiply the first term times the second term, which is negative root 5. So remember, when you multiply, the 4 is going to stay on the outside, the root 5 stays. So we get negative, because that's like a negative 1, negative 4 root 5, okay? Then we're going to multiply the two inside terms. So we have root 5 positive times positive 6. So once again, it's a positive 6 and the root 5, they just go side by side. And then the last terms, we've got positive and a negative, so negative, root 5 times root 5. So we multiply those back together. 5 times 5 is 25. All right? So now we're going to work on simplifying that. So the 24 stays. Since these have the same roots, we can add their coefficients. So negative 4 plus 6 is positive 2 root 5. And then minus, well, the square root of 25, remember, that's 5 times 5. So it's just 5. All right, and then the last thing we do is these whole numbers we can combine. So 24 minus 5 is 19 plus 2 root 5. You can't do anything with a whole number and a number with a root. So that's going to stay. Okay, so if you need help with number 4 on your practice, let me know. Now you've got 3 for you to try. So go ahead and pause the video and you're going to try those 3 problems. Okay, let me know if you need help. I should be close by you if we're both here today. Okay. All right, so let's move on to solving. So this is going to be the last section in Unit 1, okay? So when you solve a radical equation, you want to get the radical all by itself. So that means if anything's being multiplied or adding or subtracting by the radical, you need to move that by doing the opposite. Add, subtract, multiply, divide. Once the root is by itself, you're going to use the inverse operation. So if it's a square root, you square it. If it's a cubed root, you cube it, both sides, okay? And then you're going to solve for the variable. So let's look at, I've got 2 different types. Let's look at example number 1. Well, first of all, it's a square root. So what you notice is this is all inside, which is fine, and there's nothing on the outside, okay? So step number 1 is done. That root is all by itself. So that means we're ready for step 2. Since this is a square root, we're going to square both sides. So that's an exponent of 2. What happens is the square root and the square cancel. So you're just left with whatever is inside. And then you're going to do the right side. Well, 5 squared means 5 times 5, which is 25. Then this goes back to secondary 1, and we want to get x by itself. So you always want to add or subtract first, doing the opposite. So since the 1 is being added, we're going to subtract 1 to both sides. So you're left with 2x on the left, the 1's cancel. 25 minus 1 is 24. Now, what's really happening is 2x means 2 times x. So if we want to get x alone, we need to move the 2. So since that's being multiplied, we want to divide by 2. So x equals 12, okay? All right, let's look at example number 2. You want to get this radical, which is a cubed root, all by itself. But you have a 2 by it, and you have this 5. So we're going to have to move those first before we can move on to step number 2. So you always want to do the adding or subtracting first, the opposite. So since that's minus 5, we're going to add 5 to the other side. So we get the 2 cubed root stays. We can't do anything with that yet. And then 19 plus 5 is 24. Okay. Now, we still have to move the 2. Since that's being multiplied, we're going to divide by 2. So then we're left with the cubed root of x plus 1. 24 divided by 2 is 12. Now, that's all step number 1, getting the variable by itself. So now we can do the inverse. Since we have a cubed root, that means we want to cube both sides. So that's an exponent of 3 on both sides. So the roots cancel, and you're left with whatever is inside. And then you're going to want to go ahead and get a calculator and either do 12 times 12 times 12 or 12 to the third power. And it's a pretty big number. It's 1,728. But that's okay. You have calculators. And then from here, to get x alone, we want to move the 1, so we're going to subtract 1. So x equals 1,727. Okay? So get the root alone, squared or cubic, and then solve. All right. So if you need more help, let me know. But I've given you 2 problems to try. So go ahead and pause the video, and you want to try these 2. Okay, so now you have some choices. We're at the end of Unit 1, and remember there's 3 units. So if you are finished for the day and your time is up, you are welcome to turn this in to either Mrs. Eden or somebody in the office, and then you can come back on another day to continue on with Lab 2. If you want to keep going, then let's go. All right, so we are going to work on Unit 2. So Unit 2 is operations with numbers, and we're going to just be doing the basics. We're going to do quadratic operations and then complex number operations, okay? So the first thing is we need to figure out, well, what is a quadratic equation? Quadratic equation means that the highest exponent is 2. So an example means it could be x squared plus 5. Or we could have 5x squared minus 3x minus 4, okay? It doesn't matter how many terms we have, but the highest exponent is a 2. The standard form is ax squared plus bx plus c. The most you can have is 3 terms. If you have an x squared term, an x to the first term, and this is really like x to the 0 power term, okay? So when you add and subtract quadratics, adding, you just add like terms. But if you're subtracting, you want to distribute the number, which is like a -1, in front of the second parenthesis, and then you combine like terms, okay? So like if you had 5x squared plus 4 plus 3x squared plus 5. Well, when you're adding, there's like a 1 here, so we want to distribute the 1. The first terms stay the same. And then the 1 doesn't really change anything since it's positive. And then you look at the like terms. Both of those have x squared, so you add their coefficients. 5 plus 3 is 8. And then these are both whole numbers, so we can add those. 4 plus 5 is 9. And so that would be your simplified expression, okay? X squared and anything without an x squared just stays. We'll do FOIL after example number 2. So let's look at the first 2 examples. So on number 1, we're just adding. So I do have a parenthesis in the front, but really that parenthesis doesn't mean anything since there's not a number on the outside. So I can just rewrite those terms without the parenthesis. The second set has like an imaginary 1 there, and since it's positive, that doesn't change any of these numbers either. So really, I could have just erased these parentheses. And now we want to find like terms. So here's an x squared term, and we do their coefficients. 4 plus 6 is 10. Then we find the next one. This is like x to the first. Notice how I'm circling the signs, so I apply them. So I've got -8 plus 2 is -6. And then the last one is 5 and -13. So 5 minus 13 is -8. So that would be our answer. Okay. All right, example number 2. Well, the first parenthesis, there's nothing in front, so I really can just get rid of the parentheses and keep everything the same. When you subtract, it's really like it's a -1 that you are multiplying by, which changes all the signs. So -1 times 7 is -7. -1 times -5 is positive. And -1 times positive 18 is negative. So see how all the signs changed when you subtract. And the parentheses go away. So now I'm going to do the same thing and look for like terms. I would go to the highest first. So here's x squared. So we get negative 4 minus 7, or negative 4 plus negative 7 is negative 11. I have 7x and 5x. So 7 plus 5 is 12. And then our whole numbers. 15 minus 18 is negative 3. Okay. All right, we kind of did multiplying FOIL with the square roots, so we're going to do the same thing here when we multiply. And I've got two examples. This gets used a lot later. So the way it works is the 2x stays together and the 4x stays together, and we're going to multiply them. So 2 times 4 is 8, and x times x is actually x squared, because x times x, they have exponents of 1, and the rule is you add exponents. Okay, so 2x times 4x is 8x squared. Then I'm going to multiply these. I've got 2 times positive 9, which is positive 18, and the x just stays. Now we're going to multiply, it's negative 7 times 4x. So negative 7 times 4 is negative 28, and the x stays with it. We only have one of them. And then that's a positive 9, so we multiplied those. So negative 7 times positive 9 is negative 63. So you should always have 4 terms if you started out with 2 parentheses. But notice the 2x gets multiplied by both terms, and the negative 7 gets multiplied by both terms. That's why it's called double distribution. We abbreviate it with the acronym called FOIL, first, outer, inner, last. Now, we look at what we have, and this is my only x squared term, so that's going to stay. These are both x's, so I can combine them. So 18 minus 28 is negative 10. This is my only integer, so that stays. Okay, so our final answer has 3 terms. All right, let's try one more of those. So notice 2 sets of parentheses. I've got 3x, negative 2, 5x, negative 8. So first we're going to multiply 3x times both of these. So 3x times 5x. 3 times 5 is 15, and remember x times x is x squared. Then we do 3x times negative 8. 3 times negative 8 is negative 24, and the x stays. Then I do the insides. Negative 2 times 5x. So negative 2 times 5 is negative 10 with an x. And then the last terms in each group, negative 2 times negative 8 is positive 16. So my only x squared term stays, and then these can combine. You typically can combine the middle terms. So negative 24 minus 10 is negative 34x. And then this is my only integer. Okay? All right, so you've got 3 problems for you to try. I want you to go ahead and try all 3. Pause the video while you do these 3, okay? All right, we are now going to work on imaginary and complex numbers. So an imaginary number, this is going to be brand new, and it doesn't show up that often, but it does have uses out in the real world. So a number whose square is less than 0. An imaginary number is the square root of negative 1. So anytime you have, by definition, the square root of a negative number inside, most calculators won't do that, so you're going to have to do it by hand. And anytime you have the square root of negative 1, you can replace that with the letter I. Okay, it's not really a variable, it's actually a number. So when we get to the square root of 16, negative 16, I can think of that as the square root of negative 1 times 16, because negative 1 times 16 is still negative 16. And then with roots, we can break that up as long as we multiply them separately. So the square root of negative 1 is I. And the square root of 16, since that's 4 times 4 and we're looking for a double, is 4. So we actually get 4i as the square root of negative 16. Anytime you have a negative under a root, your answer should have an I on it. Okay? When you add or subtract imaginary numbers, it's just kind of like